networks are changing. So at the end of the day, you need to transmit your data. If a sensor is placed somewhere, it is capturing data but not transmitting it, it is of no use. At the end of the day, you want to have access to those data, and for it to go somewhere in the cloud, it needs to be connected through a network. Now here, as applied computing student, as sensor a system and application student, as IoT student, you need to understand something very, very important. I will repeat it many times during this course. See, your computer, when it is connected to the internet, it uses a protocol. Which protocol do you think? Anyone can unmute you and tell me, because I'm not able to see you, or at least I hear some answers from you. Which protocol your computer, normal computer, your laptop, your computer in the lab, at home, or whatever, it is connected to the internet? Which protocol it used to connect to the internet?
TCP.
Yeah, very good. So it is TCP/IP. Okay, there is a protocol shows that is called TCP/IP. Okay, use TCP/IP to connect to the internet, and we have been using this since the advent of the internet, what we call the internet. We have always been using TCP/IP to connect to the internet. Now I will tell you something. We say Internet of Things. We say our sensors connecting to the internet. Our sensors don't use TCP/IP. This is a big issue. Now this is what makes IoT not difficult, but what makes it different from normal networking that you have learned. I know you have a networking module in your second year. Have you studied OSI layers, for example, the 7 layers of the OSI?
Yes.
Yes. So the different network, the physical layer, data link layer, network layer, it goes on. So you have learned about this, and then you must have been introduced to TCP/IP. This is the protocol we use to connect to the internet. Now we have two worlds: the world of TCP/IP. Why at the end of the day I want my sensor to connect to the internet? Because the sensors need to transmit the data so as it is saved on the cloud, and I can access the data anywhere, anytime. This is a big reason why I want my data to be transmitted to the internet. Now the problem is that the internet works on TCP/IP. My sensors, the different sensors that you're going to buy, your Arduino, whatever, they are not TCP/IP enabled. This is a big issue. Now, how to make a sensor that is not designed to be TCP/IP? Your laptop, it comes directly. You have what is called your network interface card, NIC. Your NIC, it is already TCP/IP enabled. You just plug your cable. You are connected to the internet. No problem. No problem there. Or if it is not through your network interface card, you are going to use through your Wi-Fi. Your Wi-Fi, it is connected to the internet. No problem. But this is not the same for your sensors. Your sensors, they are not TCP/IP enabled. They don't use TCP/IP protocol. You're going to see our sensors use other protocols, and we will have to bridge. And this is the most challenging part: how to make your sensor, which is not TCP/IP, transmit the data over the internet, which is TCP/IP. This is one of the biggest challenge, one of the biggest thing you're going to learn in this module. And I'm already telling you from week 1 itself, one of your exam question will be based on this aspect of how sensors that are not TCP/IP, how do they communicate to the internet, to a particular cloud platform which uses TCP/IP. Definitely you will have a question in the test and in the exam as well, because this is a main point of discussion in this module. I won't be discussing it today, but this is a main point. I'm already telling you at this point in time that because these are two different worlds, the networks for your sensors and the network for internet is not same, since there is a word network here. So okay, so more notes. When we talk about sensors, we talk in terms of millions of sensors being deployed that needs to be connected to the internet. I mentioned about this M2M communication, but machine communication to machine and sensors communicating to sensors, and we are talking about billions of sensors that needs to be connected eventually to the internet. So it's no more about computers, about laptops or whatever. We're talking about billions and billions of sensors. Okay, we need the proper networking solutions in order to be able to communicate to the internet. Okay, so maybe another point that I should already tell you here. With respect to the internet, always we have been saying that we need to have higher capacity, higher speed of internet. You want when you have internet at home, okay, your internet connectivity, you want it to be high speed. Why? Because you want to download, watch movies, your YouTube channels, or whatever. So we always try to look for higher capacity in terms of our internet. But for sensors, you will notice as we proceed in this module that it is a different story. Sensors do not transmit high volume of data. They transmit very little data. So it seems that for sensors, for IoT, you don't require that large volume of a capacity for your network. You see, it is somehow different from what we want in internet and what we need in IoT. Okay, so we want smarter networks. We want data-centric network, because at the end of the day, I need to transmit small volume of data, but very frequently. Every, I don't know, few seconds, 15 seconds, I need to transmit some data. And the network needs to be context aware, that they understand their situation. I will explain as we proceed what it means by a context aware. Let me proceed. Okay, these are some traditional definition of what is an IoT, what is a sensor system. You are going to see, I'm going to use the term interchangeably, that is IoT sensor system. It is the same thing for me. It says that it's a system of integrated computing devices, mechanical, digital machines, objects, even animals and people form part of the network. At the end of the day, we monitor animals, we monitor people. They become a node in the network. Okay. And without requiring human to human or human to computer interaction. So by themselves, they are doing the monitoring, capturing the data, and transmitting the information. You can go through this definition. Let me proceed. Yeah, let me give you an overview. What is this? From where we have moved to where we have reached. So you know the internet in the 80s, or first time we have used the internet was to interconnect a few machines together. Then we have extended the internet to connect personal computers, PCs, all around the world through this common network. If you have studied some history of computing, you will know the American defense, the DARPA project, from where we have got this internet, the network that we are currently using. So at the start, it was mainly for computers, for machines, big machines. Then in the year, we can say 90s and 2000, we started connecting mobile devices to the internet, our laptop, our mobile phone being connected to the internet. I wanted to have internet when I was on the move. So this is something very normal nowadays, but at that time, it was a big breakthrough. Then we started connecting smart devices, our tablets, our smartphones, and anything. This is again a big change in the area of computing in general, where I can practically do anything that I was able to do on my PC. Now on my smartphone, I can do it. My browser internet seamlessly, type letters, check emails, and anything. This is when we were able to connect a smartphone to the internet. Let me proceed. Then we have noticed in the year 2010, we started connecting things to the internet. Our car is connecting to the internet in order to give us navigation, roads, directions, and everything. Refrigerator, washing machine, surveillance cameras, I have explained earlier. We are starting to connect such devices to the internet to transmit data. And recently, we can say, as from year 2010, 2015, now we have reached 2020, we are connecting a number of sensors to monitor all sorts of things about our environment to the internet. So all this has given rise to this term that we know today to be Internet of Things. This is from where this term comes, Internet of Things, and this is what you are going to learn in this module. Okay, you can see this chart here is an interesting chart. It is showing up to 2020. We are in 2020. So let me explain to you what do you have in this in this chart. You'll see at the top the world population. World population 6.3 billion in 2003. We have already reached 7.2 billions. Okay, 2015, and number of connected devices over the internet. Next row you will see 50 million, 12.5 billion, 25 billion devices, and it is expected by the end of this year we'll have something like 50 billion devices connected to the internet. Just to compare the number of devices connected to the internet and the number of people on Earth. And down you will notice down the number connected devices per person. In 2003 it was 0.08. Today it is around 6 devices that are connected per person or on the internet. Just to tell you that in 2008 the number, we were having more devices connected to the internet than we have number of people on Earth. Just to tell you that the number of devices connected to the internet has increased a lot. And you can see here it's becoming a world move from Internet of People to Internet of Things, where practically anything is being connected to the internet. Intelligent system for more connected world, whether it is machinery, whether your businesses, shops, cars, everything being connected to the internet. This is the evolution that has happened. At the start, we have Internet of Content. We wanted to check email, to see web pages, whatever. The Internet of Services with Web 2.0, e-commerce, productivity and everything. The Internet of People with social media, Skype, Facebook. This was known to be Internet of People because we were connecting people with people through Facebook, YouTube, and everything. Now we are talking about Internet of Things, that is machine to machine a connection. This is why you are studying today Internet of Things, and these are the evolution that we had with respect to Internet of Things. Okay, so you can see here the world is the index here. Okay, take the world online, take control of the world. Let the things talk to each other. Next, this is what has happened. The things talks to each other. And let things become intelligent. This is in this direction that we are moving now. Let the things, the sensors, do the work on our behalf. They know what to do, when to do, what exactly, which alarm to trigger. Everything is taken care by the sensors through the use of AI, for example. Okay, the focus as after you in this course will be to learn the common issues, okay, the primary use cases of IoT system, the different architectures that are used, the different protocols, data link session, communication protocols, and the application in the various domains. I think in my introductory part, I have already explained this to you. And we will try the Internet of Things. Basically, it is three vision: the things that are there, the internet that is there using TCP/IP. Okay, and the semantic that is there. Semantic means how do you reason about it? How do you make sense about it? Everything together become the Internet of Things. It's always good also to know about this, the Gardner hype cycle. This is what is called the Gardner hype cycle. Just to show to you what has happened with respect to Internet of Things. Quite recent one from last year. I don't think they have published for this year yet. This is the hype cycle for Internet of Things. For example, at the start of the graph here, this is just started. Blockchain and IoT, for example, this is just started. Okay, now we are talking about it. Things that are already at the high on the hype. Okay, they are quite popular and everything. For example, digital twin, IoT security and everything. Things that we have already got good understanding about it. For example, IoT platform is going down. Okay, we have already got the good understanding. This is through of this development. And then slope of enlightenment, that is where it is being used heavily in the industry and everything. For example, IoT integration in businesses, indoor location of assets, identifying things and everything. So this we are already using it very well. Actually, all technology follow this curve here. At the start, we don't know much about it. We have high expectation about it. We learn more about it. There are issues and everything. We solve those issues and then we apply it. It becomes useful in consumer products, for example. This is for IoT, for Internet of Things. Yes, you're going to learn about different application areas. Okay, in this module. As after you, IoT is being used in all sphere of socioeconomic development, whether it is consumer products, whether it is healthcare, in businesses, shopping malls, shops, industries, in manufacturing companies or whatever, in transportation, security and surveillance, for smart infrastructure, for citizens, for municipalities. So it is used practically everywhere. There is no domain where we are not using IoT as such. And it is giving rise to what is called the smart grid, where all the services that are being offered by for utilities and everything is being controlled by network. Okay, these are just a few case studies. Smart egg tray, and you need to start reflecting on your mini project. For your mini project, these are things that maybe you can explore. Okay, a smart tray that tells you how many eggs do you still have in your refrigerator or whatever. Smart washing machine, you can read about it. Smart lighting, depending whether you are in the room, you are not in the room, detect what is the intensity of the light that should be given. We should dim the light automatically. These are things that you can explore. Smart AC, whether there is a person, whether we need to increase temperature, reduce temperature. Smart sleep system, you can see what it is about. Smart weather station, to deploy sensors so as we have micro level data about the weather and take corresponding decision based on those data that we are receiving. Smart slow cooker, integrating IoT in our appliances in the kitchen, for example. Smart garbage can, that is, we know how much our garbage bin has been filled, whether we need to deploy a garbage collector in order to collect the garbage or whatever. So in order to optimize in terms of the different resources. Smart gardening, I have even final year project students that have work on this, where we have deployed some sensors in the glasshouse of the University of Mauritius at the university farm to monitor the growth of the plant, to monitor how much water, humidity, the soil humidity and everything, and then decide about the temperature that is ideal for the plants and everything. So you can have an IoT system monitoring different sort of plants, for example. Okay, so as after you, there are different types of application, whether it is for transportation, to know where our vehicle is, to optimize in terms of the road that it should take and everything. So this is the technology roadmap. At the beginning, it was RFID tags. Then we started to have cameras. Then we started to have localization, GPS, and everything. Then with miniaturization, where we have a small electronics and everything, where it is being integrated in our real world. And then we use software, software agents in order to make those sensors become intelligent. Some enabling technologies, you can see a list of technologies here, whether it is RFID, your smartphones, there are many sensors there, smart objects, machine-to-machine communication, you're going to learn about it, a number of protocols, ZigBee, 6-low wireless PAN and everything. And obviously, this is generating large volume of data at the end. After your sensor is not generating large volume of data, it is one that is a few bytes only. But when you take millions and billions of sensors together and transmitting data, obviously you get very large volume of data. And the cloud also is playing a big role there. You can see the 3 dimension that I have already mentioned earlier. Those system, you can use it anytime, at any place, and on any things. So this is the 3 dimension that we are going to study in IoT. This is the IoT ecosystem. Now you need to know that IoT consists of many layers. Okay, you can see the protocol. So down here, let me show you. Down here, this is the equipment, the sensors. A number of sensors, compatibility of the different sensors, sensibility of the sensors, what are they capturing and everything. Then this is a communication. We need to transmit the data using some communication technology. Okay, this is a sensor data, integrating it in the platform, knowing about the position or whatever. Performing analytics on the data that are being collected using machine learning, predictive analytics, and all those data saved on the cloud. You can see cloud here, and actually accessing it through a mobile application. this is there. And cut across everything, you have security that needs to be maintained, and then management of the data. And at the top, you see the application services that it provides for energy management, for entertainment, for health, for education, transportation. This is the ecosystem. You can see the same thing here in simple, using simple diagram. Down, you have your equipment. Above your equipment, you have your network for transmission of the data. Here, you process the information, and then to provide a particular service for environmental monitoring, for green building, whatever, to integrate it in the real world. This is a typical IoT architecture will consist of these parts. We are increasing, as I've told you, in order to capture those data, to transmit the data, to do some processing locally within the network. We use what is called a microcontroller. Okay, earlier I mentioned about MEMS. MEMS stands for micro electromechanical systems. Okay, these boards have become, these are computers basically, and you can hold it in your hand, in the palm of your hand, very small boards. You are going to use this one in the lab. In the lab, this one you're going to use, Arduino. Now, Arduino, you have different version, Arduino, Arduino Sudoku. There are so many versions of Arduino. Arduino is I think if I'm not mistaken, it is an Italian company, and their board has become very, very popular all around the world. The next most popular, I think it is Raspberry Pi. Okay, you can see it. And there's a big difference between an Arduino board and a Raspberry Pi. An Arduino board is less powerful, and a Raspberry Pi is more powerful in simple terms. But you have so many. There are, I can say, hundreds of microcontroller board. Okay, and in this module you will make a difference also between a microcontroller and a microprocessor. Not to confuse with a microprocessor. A microprocessor is a processor that you have inside your computer, inside your laptop, inside your PC. Okay, but here we are talking about a microcontroller. There's a big difference between a PC and a microcontroller. We will make the difference in one of our discussion. Don't worry about it. But these microcontrollers, okay, they have some internal memory. They have a processor, okay, and they have inbuilt ports through which you communicate to the microcontroller. Our next, we'll have one complete chapter on microcontrollers anyway, as we proceed. Okay, and then in order for you to mount mount a system, okay, you will need to do a number of connections. You see in this diagram here, the white board behind there is called a breadboard. Here is a circuit. You have built a circuit, okay, connecting a few sensors to the board. Those sensors will be monitoring the data and transmitting it in the on the board and doing some processing. Actually, you will have to do this in the lab. This is when I have told you will be building IoT system in the lab. These are the things that I'm expecting you to do. I will show you how to build a very simple circuit where we write a program that performs some operation on those sensors. So basically, this is my microcontroller. These are the circuit with on a particular breadboard. This is a display that you can connect to see the data. If this board is not connected to a computer where you can see the data, then you connect a display where you can see the data. Okay, so there are all sorts of sensors, okay, that are available on the market, okay, whether it is position sensors, acceleration sensors, electric magnetic sensors, water sensors, acoustic sound sensors, humidity, moisture sensors, a wide variety of sensors. Now you need to understand the difference between a sensor and an actuator. There is a big difference between a sensor and a sensor is a device that captures data for you from the environment, a noise level, for example, or position of an object, whatever. This is called a sensor. Whereas an actuator is a device that it doesn't capture data, but it performs something on the environment. For example, opening of a door. Okay, someone has come in front of a door, the door needs to open. So it is the actuator that do the actual work of opening the door. So it is a device that forces the door to open. So you use an actuator. You use a sensor to sense that there is a person in front of the door. This is sensor. Then that you stop the actuator to stop opening the door. This is the actuator. So the actuator is a mechanical part that performs something on the environment. As I've told you, there is a wide variety of sensors. So it's good that we familiarize ourselves with the main providers of sensor. Many of those sensors you see it on AliExpress and everything, but some very reliable providers of sensor. You have Adafruits, SparkFun, Libelium, Texas Instrument, Silicon Labs. So these are popular, reliable providers of sensors. Let me continue. Okay, so I think let me check what do we have. Okay, let me. I know that I've been talking since the start, and we are on an online mode. And anyway, this set of slides are planned over 2 weeks, so no issues about it. Let me see you online. Okay, I'll stop sharing. Okay, so I know that to follow online like this is not easy. So this is why I've already introduced the main parts there. There is a protocols and the standards part that you're still I still have to complete. So I prefer a stop the lecture slightly earlier here, and as after you, I will plan the lab accordingly. Okay, so next week we can try even to plan a break and then restart if the 2 hours seems to be quite long, especially in an online mode. So our lecture will still be at 10:30. Yeah? So 10:30. I don't know the link that I will try to use the same link that we have used today, because it is associated with the Google Classroom. All the materials are already posted in the Google Classroom for the week 1. I'm not issuing any assignment for this week. Most probably next week you will get short assignment. That I want you to do those assignments, short assignment, within 2 hours or so. You complete the assignment, you submit. Okay, because these will be mainly technology reviews. Okay, and then once the equipment are ready, I will call you in the lab for working with the real equipment. Okay, let me have some questions from your side based on what I have just explained today. Yes, from your side, any question? I've started introducing the IoT ecosystem. Okay, we'll complete it next next week. My voice was okay? The presentation was okay? Is there anything to improve there? You're able to follow?
Yes, it was clear.
It was clear to everyone, because
yes.
I'm not using a headset.
Yes, it was clear.
On my laptop. Okay, I see a number of messages from on the chat from good. From Banju, Bagalu. Okay. So one piece of advice before I leave you. I know that you had a lecture in the morning as well with Dr. Bechu. So be connected and stay in touch, because I know that now it is online. Okay, stay connected, and don't miss your lectures. You know, the responsibilities is more on you now. Okay, and believe me, if you start missing lectures and everything, you will start experiencing difficulties. You will not know about it, but eventually you will be missing important points, and then when you will be taking the necessary exams or whatever, then you will be experiencing big difficulties. So be serious. Anyway, you are level 3 students. I don't have even to tell those things. You know your responsibility. Okay, so you know how it works. So I count on your good judgment. Okay, stay connected and to follow all the lectures attentively. Okay. We have been told to have a Google Sheet, Excel Google Sheet, in order to take the attendance. I've not created it yet, but I'll try to create for every week a Google Sheet where you can put your attendance. This is just a formality for formality's sake. Otherwise, for me, it is accepted to you. You are responsible. You have to do your necessary work. Okay. On your side, any question, anything that you want to ask? So no lab this week. I say it again. We will not have any lab session this week on Thursday. Hopefully, I will tell you for next week. I need to check with respect to the equipment and everything. Okay. And anyway, if next week we are not having any lab, I will issue your first lab assignment. I call it lab assignment because you can use your lab time to do this and submit. And I will put the submission deadline on Thursday after your lab. This will be counted towards your coursework, so be very careful. It will be a short assignment, but that you're expected to do in a very short period of time and submit it in the Google Classroom. And as soon as you're doing it and you're doing it at a reasonable level, you will get your full mark. Okay. Last year, mainly those who have not done it or have not paid attention to what I have also whatever, they have missed marks. Otherwise, all of them, as soon as you're doing it and it is up to certain level, I will give you full mark, because it is more for doing it, for taking the time to sit and do it, because I want you to learn from those assignments as well. Because, for example, I won't be able to search for all types of microcontrollers and show you in my lectures, but I give you the work to see what is available on the market, what is the price, what are the different specification and everything. So as you become familiar with it, you learn about it. So these will be done through those very short, simple assignment that I call technology reviews. Yeah, no question from your side? No question. So if you don't have any question, I stop recording.